In previous modules, we've looked at how to calculate the present or future value of a single cash flow by calculating its value at a different point in time. And we've looked at how to compare or combine multiple cash flows by calculating their present or future value at the same point in time. In the previous module, this module, and the next module, we will use those same principles, but we will use some shortcuts, which can sometimes avoid having to perform a large number of calculations when there are many cash flows. As in the last module, even though these shortcuts give us the most value with a large number of cash flows, we will use just a few in our examples. As we have seen in a previous module, in principle, we can calculate the present value of any series of cash flows by treating each of them as a single cash flow. This formula shows in general terms how to calculate the present value of n cash flows, assuming that they are to be discounted at the same interest rate, R. The shortcuts that we are looking at in the previous module, this module, and the next module are all based on the assumption that the interest rate R and the cash flow C stay constant. The exception to that rule in the previous module was the case of a growing perpetuity. If we have the same cash flow in every period for a finite period of time, in this case $10, the name we give to that series of cash flows is an annuity. We could calculate the present value of these four cash flows by using the techniques we were introduced to earlier, treating each cash flow separately. Before we look at a shortcut formula for the present value of an annuity, it is important to emphasize again that the basic formulas that we use assume that each cash flow occurs at the end of each period. When that occurs, we call it an ordinary annuity. In this case, we have a 4-period ordinary annuity, with $10 cash flows occurring at the end of each of 4 periods. In the last part of this module, we will now consider what happens if payments do not occur at the end of each period of the annuity. In this diagram, we again have a 4-period annuity consisting of 4 payments of $10, but now the payments occur at the beginning of each period. We call this kind of annuity an annuity due.